A translator at the United Nations hears a sentence, understands it completely, then reconstructs the meaning in another language in real time. Computers can now do something similar, but they don't actually understand anything. And that gap is exactly what NLP is about. Natural language processing, NLP, is the field of computer science and machine learning focused on getting computers to work with human language. Text, speech, meaning, context. Think of it like teaching someone to read who has never seen a sentence before. Except instead of one person, you're doing it at scale, across billions of examples, and the reader has no lived experience to draw on. None. Every pattern it recognizes had to be learned from raw data. That's both the challenge and the achievement. You're already inside NLP dozens of times a day. When Gmail suggests how to finish your sentence, that's NLP. When you ask Siri a question and get a real answer instead of a list of links, that's NLP. When a bank flags a customer support message as urgent because of its tone, that's NLP too. Without it, every interaction between humans and software would require humans to speak the machine's language. Structured commands, rigid syntax, no ambiguity allowed. The reason ChatGPT can answer a vague, messy, half-formed question and still figure out what you meant, that's not magic. That's decades of NLP research becoming fast enough and cheap enough to run at scale. Understanding NLP means understanding why AI language models work when they do and why they fail when they don't. When text enters an NLP system, the first thing that happens is called tokenization. The system breaks the input into smaller chunks, tokens, which are roughly words or parts of words. The sentence ChatGPT is useful might become 3 tokens. The word unbelievable might become 2, un and believable. The model works with these tokens, not raw characters. From there, the model needs to understand relationships. Which words modify which, what the subject is, what the intent behind the sentence is. Early NLP systems used handcrafted rules for this. If the sentence has this structure, apply this grammar rule. Fragile and slow to scale. Modern NLP uses transformer architecture, the T in GPT. A transformer processes all the tokens in a sentence at the same time, not one by one, and uses a mechanism called attention to figure out which tokens are most relevant to each other. The word bank next to river means something different than bank next to account. Attention is how the model tracks that. The model was trained on enormous amounts of text, books, websites, code, conversations, and learned statistical patterns across all of it. It doesn't store facts the way a database does. It compresses patterns into billions of numerical weights. When you type a prompt, it predicts the most statistically likely continuation of that text based on everything it learned. And if this is the kind of thing you want to actually understand, not just use, but understand, Stack Future covers one concept like this every day. That's what people mean when they say AI language model or talk about how LLMs work. Large language models are NLP systems trained at a scale that makes the patterns remarkably coherent and generalizable. Say you're building a customer feedback tool. You want to automatically label incoming reviews as positive, negative, or neutral, a task called sentiment analysis. You feed your text into a pre-trained NLP model, something like Hugging Face's pipeline function with the sentiment analysis parameter. You pass in the string. The setup was confusing, but the support team saved everything. The model returns positive with a confidence score around 0.87. Why positive? Because the attention mechanism weighted saved everything more heavily than confusing in the overall sentiment calculation. It's not reading the sentence the way you are. It's recognizing a pattern that appeared thousands of times in training data. Complaint followed by resolution tends to land positive. Understanding that mechanic tells you exactly why the model might get it wrong on an industry-specific review with unusual vocabulary it hasn't seen before. The fix isn't to complain about the model, it's to fine-tune it on domain-specific examples. That's the decision NLP knowledge puts in your hands. NLP is how computers navigate human language by breaking text into tokens, modeling relationships between words, and predicting meaning from patterns learned across massive data sets. That process is inside almost every AI tool you use today. Next up, how AWS S3 works, explained simply, because storage is more interesting than it sounds and it's everywhere. If this actually taught you something, hit the like. It helps more people find this stuff.